Hi, welcome to lesson number 1 of our module 5, which talks about Spark SQL. So let's begin this particular module by discussing a brief history about the Spark SQL and what is the advantage of using Spark SQL. So in the last lesson and especially in the last module, we have been dealing a lot with shared variables, broadcast variables and accumulators, and a lot of RDD operations as such, right? In this particular lesson, we are kind of like getting introduced to one of the most widely used Spark library, which is called Spark SQL. And we will specifically talk about the history behind Spark SQL, the background, and why it is used, why exactly Spark SQL, and some certain features of Spark SQL. So let's rewind and talk about history, right? So if you really look at something called Spark SQL, it all started with a project called Shark. So the creature shark, which lives in the sea, you can say. So basically when Spark came into the world, it was having a lot of wow factor. You know, it's really fast, it does in-memory computing, and it is based on the directed acyclic graph and so on and so forth. Well, that was a good thing, but however, people were finding it very difficult to have a SQL-ish interaction with core Spark. So in the Hadoop world, we already had something called Apache Hive, and Hive is a typical data warehouse, and it is expected to be slow. Now, if you look at a brief history, after Hive, what happened was that we got interactive query engines. For example, Cloudera came up with something called Impala, and Hortonworks came up with Hive along with the Taze execution engine. So the SQL world was slowly trying to acquire speed, I believe. So people were not really happy with the speed of Hive, even though Hive is very, very reliable. It can be used only for really slow batch jobs. So people were thinking that, hey, what is a solution? I need to have interactive queries. I want to use SQL on big data. What can I do? And that is where these tools like Impala and all came in the middle, right? And when Spark came into the world, people initially had a lot of expectation regarding writing custom SQL on top of Spark. And that is exactly what the original Shark project provided. So Shark was a project which allowed people to basically write SQL on top of core Spark. And then that will be transitioned into a series of RDDs, and Spark will execute them and show you the result. So basically for data analyst folks and all, Shark was a great project, right? And what happened over a period of time, somewhere in the end of 2014, mid to end of 2014, this Shark project was transitioned into another name called Spark SQL. Now Spark SQL is a new SQL engine which is designed from ground up for Spark. And it's very simple. It provides you an option to write SQL on top of data, and it is blazingly fast. And by around 2015, we had Hive on Spark, which means the Spark SQL was able to communicate with any existing Hive distribution, so that people who were already familiar with Hive were easily able to migrate to Spark SQL, right? Slide number. Now, if you look at it in a closer way, Spark SQL is basically the Spark's module or set of libraries for working on structured data. Now, the advantage of using Spark SQL is that you can either use your SQL language. So when I say SQL, it can be the original structured query language, or it can be your Hive query language, which is called HQL, or you can even interact and analyze your structured data using the data frame API. So we will come to this very soon. So in Spark SQL, your data is represented as a data frame. And if you are coming from the Python background, then you might be familiar with the packages like pandas and data frame, wherein you can project a structure to an existing data and query that without using SQL. Now the same is possible in Spark SQL as well. And you can have Java, Scala, Python or R code on that. And as we have learned, the original project was called Shark. And it was part of the Apache Spark distribution from 1.0 version onwards. That's April 2014. You can run traditional SQL queries or Hive QL queries and then analyze your data. Now let's also look at some of the challenges and solutions that we have. Now one of the challenges in the big data world was to perform ETL from different data sources. Now when I say perform ETL from different sources, we already had the Hive solution like I was explaining, but Hive tends to be very, very slow, right? So we were not really able to utilize the interactive nature of queries while performing ETL operations. And the second challenge is probabilities such as advanced analytics, which includes machine learning, graph processing, so on and so forth. So in any traditional, I won't call it as traditional, in any big data related applications these days, you might want to explore a lot of machine learning algorithms as well as graph processing. And this was very, very cumbersome in case of Hadoop and its siblings, right? And on top of that, people were really interested in ETL analytics. Now, with the Data Frames API, we are kind of like solve the problem of ETL analysis. Now, with Spark SQL's Data Frame API, you can practically query any structured or semi-structured data using SQL. And you can even use Hive QL. Now, if you are wondering what is the solution for machine learning, there is something called MLlib, and the solution for graph processing is GraphX libraries, which we will see as we go towards the course. So here you can see a small graph which basically shows you the number of commits per month for the Spark SQL project and the number of contributes. And as you can see, the graph is from March 2014 till mid of 2015, and you can see a consistent rise in the graph, which means Spark SQL has become one of the most active sub-projects within Spark community. And we have been seeing an increase in number of commits and contributors as of now. So what exactly is Spark SQL, right? So obviously it allows queries through Spark. All the operations are based on schema RDD. Now hold on for a moment, because this line needs some explanation. All the operations are based on schema RDD. Now it is very specific because in the original version of Spark SQL, or I can say that in the Shark project, we were representing the data in a table-like structure called a schema RDD. So schema RDD is a table-like structure in which you represent your data in terms of Spark SQL. And it is very rare that you see schema RDD today, because right now we are in Spark 2.0 version, right? And schema RDDs existed long back. And if you are on Spark version 1.5, 1.6, then you will see something called a data frame. Now, throughout this course also, we will be mostly using the terminology called a data frame. A data frame is also a table-like structure that will allow you to, project data, which is extensively used in Spark SQL. So schema RDD and your data frames are very similar. The only difference is that schema RDDs are in Spark version 1.0 and data frames are in Spark version 1.5, 1.6 and all. Now, if you go beyond Spark 2.0 version, you will have data frames and data sets. There is also another type of representation called a data set. But I don't want to confuse you a lot. So just understand that instead of schema RDD, we will be using something called a data frame. A data frame is nothing. It is made up of something called row objects. Basically, it is a collection of rows which is having different columns. So think about a data frame like a table. Very simple, right? What is a table? A table is a collection of rows with named columns, right? A data frame is also a collection of row objects which is having named columns. That means the basic entity in Spark SQL is called a data frame. Now, if you look at core Spark and if you want to do anything in core Spark, the first requirement is that I need an RDD. I cannot do anything without an RDD in core Spark. Now, in terms of Spark SQL, the core requirement is that you need a data frame. Once you create a data frame, then you can query that using SQL or HiveQL or any other things, right? So we will see this in depth as we go along, don't worry. So what are some of the features of Spark SQL? So obviously there is Hive compatibility. So Spark SQL can access Hive's metastore and read the metadata. It can even store temporary tables in Hive's metastore. So that means all the tables that you have created in Hive can be called in Spark SQL and you can analyze them really fast. And you have unified data access. What this actually means is that Spark SQL natively support loading data from multiple sources. You can load your data from HDFS. You can load your data from a local file system. You can load your data from something like Amazon's S3. You can load your data from RDBMS systems, so on and so forth. So you get kind of like a unified data access. And it is integrated. You can mix SQL queries with Spark program. What does that mean? That actually means that if I'm writing a Spark application, I can have a native Spark code which talks about RDDs. I can also have Spark SQL code. They are not completely different, right? And you obviously have standard connectivity, JDBC or ODBC, and it inherently uses the amazing scalability of Spark. Now, why somebody should go for Spark SQL? Obviously, very less code you have to write and you can read very less data. And there is a built-in Catalyst optimizer that will take care of compiling and optimizing and creating a plan, execution plan for your queries. And obviously, you can integrate very well with Hive. So here you can see some examples of the industries which are using Spark SQL. So we have retail, finance, entertainment, and e-commerce. So Spark SQL can be used for generating faster queries for reporting, data mining, BI, visualization, analytics, and so on and so forth. So a common question will be, hey, can you please compare Hive and Spark SQL? So let's do that. So, well, Spark SQL is basically a library where Hive is a framework. What does that actually mean is that Hive is an independent framework, and you can install Hive separately, and obviously it needs an execution engine, but it acts like an independent framework. On the other hand, Spark SQL is a library. That means Spark SQL cannot do anything alone. It in turn refers to the core Spark libraries. And in Hive, the meta store is mandatory because in Hive, you are persisting the data. That means in Hive, you have to create a table, then load the data, and that table remains permanent unless you delete it or drop it. But in Spark SQL, the meta store is optional. So using Spark SQL, I can project a structure, do some analysis, and then just drop off. I don't have to persist anything. So there is no requirement for a meta store. In Hive, obviously, the schema has to be declared manually. Spark SQL can use something called inference. It can automatically identify the schema, which reduces the load on the developers. You don't have to manually write the schema. Hive supports only the Hive query language, and in Spark SQL we have SQL, the HiveQL, and even the data frame API language. And obviously both are having the Thrift server, which is being used by Hive. Now this is the most important difference between your Spark SQL and Hive. Now if you look at a Hive query, and say for example the Hive query takes somewhere around 500 seconds to be completed, right? The same query in Spark SQL can be done in less than 10 seconds. So Spark SQL is amazingly fast, and you will see that when we start the hands-on. So to wrap up, in this particular lesson, we just got started with Spark SQL. We understood the background, the history, the features, a comparison with Hive, and then we just finished the lesson. So that's all for this lesson. Thank you. If you have any questions, please do not hesitate to raise a support ticket. Thank you.